I'm taking you to the journey of the shadow of environmental degradation towards the dawn of sustainable future. There's no doubt that we need energy to live. But where this energy comes from? There are two main sources of energies, we say non-renewable energy sources, that are coal, natural gas, and oil. And we have heard of renewable sources of energies, wind, solar, hydropower, and bioenergy. Nowadays, and for the last decades and decades, fossil fuels were the main source of energy. The petroleum, natural gas, oil, and coal are non-renewable sources of energy that it takes millions of years for them to form. And when we use it, and when we extract it, there's no way that we can replace it. So what does it mean? It means that we are going to run out of fossil fuels soon. These petroleums are trapped under the ground by geological formations, and there are different types of reservoirs that they hold petroleum and fossil fuel. The conventional reservoirs are the ones that is easier to extract fluid from. And imagine that there is a pool of oil underground, you drill the production well, and the oil comes out. Humans are using these the conventional reservoirs, and they produce fossil fuel, gas, and oil from it. But as I said, we will run out of fossil fuels soon. So what did we do? Did we appreciate Mother Earth for what was given to us and just leave the Earth alone? Well, of course not. There's another type of reservoirs that capture fossil fuels, which is called unconventional reservoirs. Because of the type of the formation and the fluids that has been stored there, it's not easy to extract fossil fuels from these reservoirs. But thanks to technology, the enhanced oil recovery was discovered in the last few decades. These methods are not cheap, are expensive. But we are going to run out of conventional fossil fuel. So humans started using these technologies to produce gas and oil every day. But are they harmless? I'll give you two examples. Imagine that we have a reservoir that holds gas or oil in a very tight formation that is not easy, it's not porous, and it's not easy for fluid to move. Thanks to the technology, we drill an injection well and send the little devices, advanced devices, down under the ground and fracture the rock and reservoir and push that oil that was trapped there to the production well. I'll give you another example. We detected a reservoir under the ground, but it's not mature. The oil or gas that's trapped there is not ready to be produced. And we still need, let's say, a few thousand years to make that oil and gas mature enough. What can we do? What if we cook the oil? Yeah, you heard me right. A drill injection well and send the devices down there to cook the oil. Well, can you imagine, these were just two examples I gave you, but can you imagine the effects and the harm that we are causing to the Earth? Okay, let's say that our planet Earth is big enough and little fractures and little extraction is not causing any harm. Well, I have a news for you. These fossil fuels that has been extracted and has been used can damage human beings too. We have heard about global warming. It's a big challenge. Everyone is dealing with it nowadays. And the burning fossil fuel causes air pollution. Their leakages causes water pollution. And also, the little particles in these emissions can cause heart attacks, strokes, asthma, and etc. Scary, right? Buckle up, I'm not done yet. There are other challenges that these days humans are going to deal with pretty soon. Talked about CO2 and emissions that needs to be taken care of as soon as possible. Also, we are producing waste every day more than the day before. If we don't think about anything, pretty soon the Earth would be covered with this waste. And one more time, we are going to run out of fossil fuel pretty soon. So we are going to have an energy problem. Is there any way that can take care of all these problems at one time? So far, it was a journey through a dark tunnel. I want to show you the light at the end of this tunnel. We think that bioenergy is the key. Bioenergy comes from is a renewable energy source that comes from biodegradable material. The bioenergy is produced from biofuels. So what are these biofuels? Biofuels are produced directly or indirectly from biodegradable material. It means that the material, that if they break down in small pieces, those small pieces are harmless. Biofuel, similar to fossil fuel, has been made of hydrocarbon. So what's the point? If that's hydrocarbon and this is hydrocarbon, why am I using it? Why we are thinking about it? Unlike fossil fuel, biofuel has been made of waste. For fossil fuel, it takes millions of years to be formed. But biofuels are made from general waste, agricultural waste, food waste, and etc. It's very promising. Now, how can we produce biofuel? At the University of Huddersfield, in our research group, we are focusing on different technologies and different processes, different methods that they produce biofuel. One of these technologies called pyrolysis. Pyrolysis is a thermal degradation process that breaks down the material in an absence of oxygen to small pieces that can produce biogas, bio-oil, or biochar. If I want to explain how pyrolysis works, I'll just bring in a fun example. If you have watched Back to the Future, the movie, when the doctor was stuck without a floor, I asked Marty to bring as much garbage as you can to just put it in an engine and chamber. That's the pyrolysis system. So pyrolysis receives general waste, agricultural waste, any kind of waste as a feedstock, and we put it in a chamber, it degrades it, and produces heat that can be directly used, bio-oil and biogas, those are our biofuels, and also it comes with a bonus. Biochar is a byproduct of pyrolysis system process. Biochar itself is very valuable. It can be used for carbon sequestration. It can be used for soil improvement, or as a filter for environmental remediation. So not only we are producing biofuels with pyrolysis, also the byproducts are very valuable. Another process and techniques that can help to produce biofuels is gasification. Gasification is similar to pyrolysis process, very similar, except that with the control of a little bit adding oxygen, which means that a little bit of burning is involved. Gasification, again, it receives waste, general waste, agricultural waste as a feedstock, as an input, and then biogas, bio-oil, and biochar is produced at the end. These are the images of a project in Uganda. The village that does not have natural gas or electricity. but there are tons of agricultural waste available there. A gasifier chamber has been installed there, and the agricultural waste is used to produce gas, and that gas would be used in the village. Another method to make biogas is called anaerobic digestion. Anaerobic digestion is the process which bacteria break down organic materials, like food waste. This is a really good method to take care of our food waste. I mentioned pyrolysis and gasifier before. These are good methods for agricultural waste or general waste, but specifically for food waste, anaerobic digestion showed a really promising process. Receiving the food waste from the kitchen at university, our anaerobic digestion produces syngas or biogas, and also similar to pyrolysis process, it comes with another bonus, a byproduct that's very useful. They call it digestate or fertilizer. So if you walk around this university and if you see the flowers that perfectly bloomed and green planets, remember that's on us. We just feed the plants with our digestate that we produce on site. Okay. So I mentioned few techniques, technologies, and processes that they produce biofuels. What do we do with this now? Yes, these fuels can be directly used as warming up the boilers or heat, but also it can be used to generate electricity. Another project that we are working on is using microturbine generators to produce electricity from the biogas and biofuels that we are producing. The biofuel combusts, and then it creates high-pressure gas. Then that gas would pass through the turbine and make mechanical energy. That mechanical energy through the generator creates electricity. There are gas engines that they can produce electricity as well, but there's a benefit of using microgas turbines. First of all, they have high energy efficiency, they have low emissions, and the cost, they have lower operation costs, but mainly one of the benefits that gas turbines has is that they can run various fuels. So, all these biofuels that I mentioned that we can produce in different technologies and processes, they come from waste, right? They're not one type of waste. We are talking about agricultural waste. We are talking about food waste, general waste. So can you imagine that these products, the gas, for example, that has been produced through these technologies, they all have different profile. They are similar, but with different proportion. So if I want to generate electricity, burning that gas, it needs to be purified, right? It needs to be simplified a little bit. But with these gas turbines, that they can receive different type of fuels, they can work on variety of the percentage, for example, of methane. The good thing is that you don't have to purify our biofuel. It can directly be used in the gas turbine and generate electricity. Well, the same village as I show you that the gasifier was installed in, there's another picture, that the gas engine then was connected to that gasifier. The reason was that village, specifically village in Uganda, they had agricultural waste that was the same agricultural waste that can be used in gasifier and produces the same biogas. That biogas then is used in gas engine. It produces electricity. That electricity is stored in battery tanks, and those battery tanks every day is delivered to the houses in the villages, and the empty one is collected the same day. These technologies and the processes that I mentioned, they are already well-known technologies. In our research group, we are focusing on all these processes in different and separate individual projects. We are studying the input, the biomass. We are studying the output to help to increase the efficiency, to improve the efficiency of these processes. Also, we are working on to improve the quality of biofuels, the produced biofuels. However, we have a bigger vision. We did not stop there. Within collaboration of different schools at the University of Huddersfield, the Energy Integration Lab was developed to integrate different processes and technologies that they produce biofuel and bioenergy and create on-site, I would call it a net zero village. The waste is collected from universities, waste, the food waste from the kitchens, the general waste, and we use it in our pyrolysis units, gasifier units, anaerobic digestion unit. The produced fuels then either directly uses as heat to warm up the buildings or generate electricity, again, to use it at the university or even sell it back to the grid. The byproducts also, there are benefits and bonuses that they can financially help to help them maintain the site. This site is running very soon, hopefully, and we are creating our net zero village on site on university. Our team is from different schools in university, the School of Computing and Engineering, Applied Sciences, and the Business School. And our goal is that after successfully running our pilot project, we are going to ship all system to developing countries where it's not easy to install or it's not easy to build up the system. So after testing it, we are shipping it to developing country, to the villages that we are working on. They are our partners and we are working on. For example, one example is that this project already has been started. It's been 2 months that in Kenya, they are, the feedstock and the waste has been decided that which one we are using, and they are paving the ground and waiting for the shipping containers to arrive to create a net zero community. So cheers to the greener future. Thank you.
Well, thank you, Gina, for a fascinating presentation.
No, thank you.
Very well done.
Thank you for listening.
No problem. It was really great to see the university's feeding its own plants. I didn't know that for a start. And also that we're helping developing countries like Uganda and other developing countries. So that's great to hear that the university is so involved in pushing the green agenda. So again, congratulations to you and your research group on doing such impactful and meaningful work for society.
Well, thank you.
So just to kick things off, I've got a couple of questions for you that I've been thinking about. The first one really is about you, and what's your motivation for becoming involved in research for biofuels and sustainability?
Well, I want to answer this very honestly and frankly. I have seen the dark side. My PhD is in petroleum engineering, and I was focusing on remediation, accurate remediation, cleaning up underground water from all these petroleum and chemical leakages. And I've seen how damages and how nasty it can be. So when I found out that there's a group that is absolutely focusing on green energy and the application of it, not just on paper, their actual real-world application, I did whatever I could do to join this group.
That's great to hear. And how's it been progressing since then? Is your motivation still strong as ever, I can see?
It's stronger. It's when you see the real life application, when you see actually how positive and improving any process can be, I'm more motivated than the day I started.
Yeah, and personally, I'm in a great position as Associate Dean for the school to see the funding bids that are coming in and the support from the University Central Research Funds for your research area.
Exactly. We have received lots of supports within university and our external partners, and every day someone is knocking on our door and they wanted to join to this project. Well, so this is really good. And the whole research group, it's been just more than a year that this has been developed, but it's moving really fast, so that's very promising.
That's great to hear. And as a railway researcher, I might be coming to talk to you about how we can use biofuels in rail at some point.
Well, that would be our honor.
Okay, so another question from me is how much greener are biofuels compared to fossil fuels, and what are the benefits and challenges to their wider adoption?
Well, they're very green. They're, as I mentioned in my presentation, it takes millions of years for the fossil fuels to form. So when biofuel is formed and created from a waste that is just a few years ago has been built up and it captured CO2 in it. So you can see the cycle that how green that can be. Well, obviously the benefit is for decarbonization toward a more sustainable cycle of the energy. But there are a lot of challenges too. What I can think is that it's not cheap. At this point, at this moment, biofuels can be expensive, but there's a way to figure out that each of these processes, how can we connect all these processes together to find the best way that financially is suitable for biofuels. Another big problem, I think that a big challenge is regularities, the laws, that depending on, it takes time to convince a lawmaker that you have done this, it didn't work out, let's change the path. It's working gradually. That's why developing countries are more open to try, and they are willing to bring these sources back there.
That's interesting. I mean, we've seen it with electric vehicles, haven't we? You know, the government policy is sometimes ahead of the science, for instance. So I think there's a balance there between when governments come in to provide subsidies and support and not just try to get back in some voters online for a bit of a green agenda. So yeah, I think it's great to see there's a development path for biofuels.
It is. It's in some countries a little bit slower. Some countries, they're really willing to start in testing it. Fortunately here, the government is supporting it. We just need to find the right path.
Yes, and as a motorsport fan, not just railways, it's good to see Formula One is adopting
Yes,
biofuels as well. So,
that's very interesting.
Maybe you can get me into one of those F1 teams. Great. All right. Well, this one is a little bit more of a techie question. I'm going to hand over to the audience for some questions. But I'm an engineer, so I have to ask this. So what's the anticipated overall efficiency of the pyrolysis process based on the energy that's required for the production process? So you're putting energy in and you're getting energy out. So how does that sort of overall efficiency look?
Yeah. Well, I would say it depends. It absolutely depends on the feedstock.
Right.
So the pyrolysis, the way that it works is that we're increasing the temperature. That requires energy, right, to break down the material. Now, imagine that our waste is wet. So it requires higher energy to, first of all, dry it, then break it down. But when we are using, let's say that the forest waste that are not that wet, so the energy that it requires is lower. But also the waste management is not cheap. especially for some type of waste, let's say medical waste. It's very expensive to take care of medical waste. In that case, pyrolysis is a very good solution for that. So it depends, I would say.
So you're weighing it against the benefits of, obviously less landfill and more efficient waste disposal is one of the benefits of the process.
Yes.
Even there's a little bit of an energy cost.
Yes, and also what we are doing in Energy Integration Lab, when you're integrating different processes and different technologies, some of these units, they produce heat while they are working, and that heat just releases in the air, in the atmosphere. What we are trying to use the same heat to dry our feedstock before pyrolysis it.
So you've thought about that part of the cycle?
Absolutely, yes. That's the really nice thing about integrating all these systems.
You can still have a drying process as part of that loop.
Yeah.
Great. Well, thank you very much for your questions. I'm going to open it up to the audience. If I've got any questions from our audience in the room here at Huddersfield or online, then would be gratefully received. We've got one online. Okay, so the question was just for the benefit of those online. What entry routes would you suggest for people that are interested in getting involved in the sort of research that you're doing?
Well, I would say that don't think about it, just do it. Well, when you're thinking about future, it doesn't look promising at the moment. It's a little bit dark. At least how I feel now is that I can sleep pretty well at night. But if someone wants to go through this path, it depends on where they are located and where they want to study. There are always sources of biomass in different places in the world, different countries, different places. It depends on where they are located at. And based on that, there are other companies, other research groups that they are focusing on different technologies and different methods based on the biomass that is available in the area. I would suggest to think about it, think about any waste that is around the area that they are living, and see that if there's a research group or anyone that's dealing with it, a little bit study there. I guarantee that you would love it. You would love it, and you're going to continue research in this field.
And I guess it's a multidisciplinary activities, and we've seen three schools involved.
Yeah.
So again, that helps open the routes to entry, doesn't it? If it's a wider background, if you like, in terms of what you need to deliver these sort of projects.
That's a really good point. I'm a geologist, petroleum engineer, environmental scientist, and I was teaching chemistry for 4 years, and I'm working in clean energy sector. It's the field that if we have mechanical engineers, we have electrical engineers, chemists, chemical engineers, even anyone that is in medical sector, there is a job, there is something for them, a role that to do in any different areas, any field.
So we've also got the sense of a global disaster resilience in the University of Huddersfield. I would imagine that they work with a lot of developing countries. There could be some links there as well from even widening disciplines even further.
Yes, if I want to count it, I can go on and on for hours on where we can actually work on. That's why we have, I would say that at the moment we have more than 12 industrial partners in our research group at the moment.
That's great to hear. Okay, so the question was, what's the capacity ready for biofuels? How much of the existing energy sources can they replace realistically, in your view? Obviously, it's a developing picture, I'd imagine, but...
Yeah, this is what we are working on in our on-site lab that we are working to see that how much we can produce and how much we can use it. So again, since it's a really vast area, it completely depends on the type of waste. For example, I'll just give you some example. For example, cardboard and wood waste, they produce more methane compared to slurry waste. The methane gas, the biogas that they produce contains 80% methane. So these methane can be replaced as for natural gas. But if the feedstock does not produce as much methane compared to natural gas. Then you have to mix it with natural gas. I would say that the technology is pretty new. We're working on the efficiency of it. And we are starting on developing this little village that runs on the waste that is produced on this village. And I'm sure that if we are working on these technologies and a little bit improve the whole process, depending on the feedstock, I'm hoping one day it would replace it with the other fossil fuel sources that we are using. But at this point, I cannot give the exact percentage, but we are working step by step a little bit.